Professor Belfrost's science class is back.
Wow, this is our fourth lesson on the chapter of equations and quantities, and welcome back to my lesson. Okay, so today we are going to continue our discussion mathematics. I'm really happy that you stay with me, and let's review some of our last lesson. So yeah, we can find the square of any negative number like with a positive number, but here the root is not real. So uh if the value in the radical is negative, so the root is said to be an imaginary number. So the imaginary number of square of minus 1, it is I. Okay, so imaginary number differ from real number in that the square imaginary number produces a negative real number. Okay, and complex number consists of real and imaginary number. And we can do addition, subtraction, multiplication, division operation too with complex number. Also, you know that the power of I are cyclic, so the cycle is repeated continuously in order I minus 1 minus I and 1 every 4 powers. And an equation containing a second degree polynomial is called a quadratic equation, and often the easiest method to solve this is by factoring, which means to find the expressions that can be multiplied together to give the expression on one side of the equation. Okay, that's done for the review. Let's start our today's discussion. So I want to review the last lesson on quadratic equation by showing you another problem on this to make you yeah, to test you to examine if you still remember how to do factorization in the quadratic equation. So say we have x squared plus 8x plus 15 with us. So how to factor it? Yeah, first we need to find two numbers whose product equals 15 and whose sum equals 8. And here's the list, but the one that suits our need is 3 and 5. Okay, so we make the pair x plus 3 times x plus 5. So for x plus 3 equals 0, the solution is minus 3, and x plus 5 equals 0, then the solution is x minus 5. So the solution is minus 5 and minus 4. Minus 5 and minus 3. Now second example, solve the difference of squares equation using the zero product property. X squared minus 9 equals 0. Okay, so actually this is not very difficult, and we can factor it out. Okay, so x plus 3, x minus 3, that is the factor of this square root equation, and squared I mean yeah, of this equation, of this quadratic equation. And for x plus 3 it is minus 3, for x minus 3 it is 3, the solution. So the solution to this equation is 3 and minus 3. Okay, in the previous lesson we have discussed how to factor out the quadratic equation if the leading coefficient is 1, and today we'll learn how to do it if the coefficient is not 1. Okay, so we need to follow these 6 steps. Okay, I want you to read it by yourself. Actually, we have discussed in the previous chapter, but I will just want to remind you once again. Okay, okay, so here's the example, right? So using grouping to factor and solve the quadratic equation, which is y squared plus 15x plus 9 equals 0. So first we need to multiply the a and c, a 4, c 9 to make 36, and then b is 35. So what number will have the what pair of number will have the the multiplication result is 36 and the addition result is 35? For sure, the only pair that suits this criteria is 3 and 12. Okay, so we just replace it with proper. So 4x squared plus 3x plus 12x plus 9. Then we do grouping like shown in the slide, and we've created the proper factor, which is 4x plus 3 and x plus 3 equals 0. So for 4x plus 3, then the solution is minus 3 fourth, and for x plus 3 the solution is minus 3. And here's the graph showing the plot of this quadratic equation. Now next example, solve the equation by factoring minus 3x cubed minus 5x squared minus 2x equals 0. Yeah, first thing, actually we can factor out x term to make it having quadratic equation, so we can solve it by using the grouping method. Okay, so minus x times 3x squared plus 5x plus 2 equals 0. For minus 1 is just constant, so we can drop it. X equals 0 must be one of the factor, and now we need to solve the quadratic equation. 3x squared plus 5x plus 2. So by using the previous method, so AC equals 6, B equals 5. So what makes 5? The sum, while the multiplication makes 6. Okay, it's for so 2 and 3, right? So yeah, we can do the grouping as shown. So it yields x times 3x plus 2 times x plus 1. So the solutions are x equals 0, x equals minus 2/3, and x minus 1. That's the set of the solution. So when there's no linear term in the equation, another method of solving a quadratic equation is by using the square root property. So we first need to isolate the x squared term and take the square root of the number on the other side on the equal side. So if x squared equals k, then x equals plus or minus square root of k, where k is a non-zero number. So there's 3 steps that you need to follow to solve this kind of condition. So for example, solve the quadratic using the square root property, which is in the case x squared equals 8, or x squared minus 8 equals 0. It's the same thing. Okay, so yeah, this is very simple. By using the 3 steps that have been highlighted before, then we can easily find out the solution or the root of the square root of the quadratic equation, I mean, and it yields x squared equals 8 have the solution of x equals plus min 2 times square root of 2. So the solutions are 2 square root of 2 and minus 2 times square root of 2. The second example on this, solve the quadratic equation of y squared plus 1 equals 7. So first you need to simplify it. I mean, the constant is still not single, so you make it just 1, the constant. So you just need to move the 7 to the proper side. So we have with us 4x squared minus 6 equals 0, and you can move back to make the arrangement. X squared equals 6 over 4 or 3 over 2. It's also okay, no matter. But I think this form is better, okay, because you can directly take square root of 4. The square root of 4 is 4. It is 2, I mean. So x equals plus min half times square root of 6. So the solution are square root of 6 by 2 and minus square root of 6 by 2. But not all quadratic equations can be factored or can be solved in the original form using the square root property. And in this case, that we may use a method for solving a quadratic equation known as completing its square. How will we do this? Actually, I will show you directly the example rather than explaining the theorem. So make use of this example. For example, we want to solve for x squared plus 4x plus 1 equals 0. So here's the step. First, you see that we move the constant to the other side, so we create x squared plus 4x equals minus 1. Then we multiply the b term, I mean 4 here, with half and square it. So half times 4, it is 2, and square it to make 4. Then add the half b squared to both sides of the equal sign and simplify the right side. So we have x squared plus 4x plus 4 equals minus 1 plus 4 with us, which gives us x squared plus 4x plus 4 equals 3. Actually, this is the same as the first equation, right? And then the left side can be factored out as a perfect square. It is the square of sum of x and 2. And the right side still 3. Okay, then we just need to take square root of both sides. Okay, so the left side will be x plus 2, and the right side will be plus minus square root of 3. And then we have the solution with us, which is minus 2 plus 3, plus square root of 3, and minus 2 minus square root of 3. Okay, that's our first example. Let's dive into another example to make your concept stronger. So x squared minus 3x minus 5 equals 0. Solve for it. So yeah, by following the step, then move the constant to the right side, and then take the half of the b term, square it. So we have 9, 4. And then we just need to add the result to both sides. Okay, then we can factor out the left side to create x minus 3 halves together squared equals 29 by 4. Then take square root of both sides and gives us x minus 3 halves equals plus minus half times square root of 29. And the solution are clearly the sum of 3 square root of 29 by 2, and the difference of 3 by 29 square root of 29 by 2. That's the solutions. Okay, so we have discussed 3 methods to solve a quadratic equation so far, and here's the 4th method by using the quadratic formula, or sometimes called the algorithm formula. Okay, so actually this formula is derived as shown in the slide. I will not read it by you. I want you to comprehend by yourself. Okay, so this is how to derive the quadratic formula, or ABC formula sometimes called. Okay, so we just focus on our end result. So the formula is that x equals uh, minus b plus minus square of b squared minus 4ac by 2a. That's the formula that will make use of. So here's the example of how to apply this formula. So first one, solve for the equation x squared plus 5x plus 1 equals 0. Clearly by using the formula above. So first we need to identify the coefficient. So a1, b5, c1. Then we just need to substitute the value to the formula, and we get the result, the solution, which is minus 5 plus minus square root of 21 by 2. The second example is find the root or the solution to the quadratic formula of x squared plus x plus 2 equals 0. We just need to substitute the coefficient to the formula. A is 1, B is 2, and C is 2. Then we obtain the solution, which is minus 1 plus the imaginary square root of 7 by 2, and minus 1 minus imaginary square root of 7 by 2. That's the solution. Okay. So yeah, the quadratic formula not only generates the solution to a quadratic equation, but it also tells us the nature of the solution when we consider the discriminant. What is the discriminant? Discriminant is actually simply b squared minus 4ac. Okay, so here's the table showing the relation of the value of the discriminant to the solution of the quadratic equation. So if we have discriminant value equals 0, then only one rational solution that will occur. Okay, if it is greater than 0, there is a perfect square, so two rational solution will be obtained. If the value is greater than 0 but it's not a perfect square, then two irrational solution will be obtained. But if the discriminant value is less than 0, then two complex solution will be obtained. Okay, so let's solve it by, let's understand this concept by having example shown in the slide. Okay, so there are 4 questions here. There are 4 points you need to solve for. Actually, they are all to show you how to apply the discriminant concept. Okay, so for x squared plus 4x, we find the discriminant and it yields 0. So there will be one rational double solution. For the b1, the discriminant is 100 and 100 is a perfect square, so there will be two rational solutions. For C, the discriminant is 49 and it's again a perfect square. There will also be two rational solutions. But for D, the discriminant result is minus 80, it's negative number, so there will be two complex solution. Okay, how about is if the discriminant is, for example, 47? Can you guess it? Yeah, it means that there will be two irrational solutions. Very good, well done. So one of the most famous formula, most used formula in mathematics is Pythagorean theorem, but actually this can be used also here because it's related to many applications. So here I want to remind you again that the Pythagorean theorem is given as a squared plus b squared equals c squared as shown in the figure below. And let's see how we can apply the concept we have learned so far by utilizing Pythagorean theorem. Okay, so yeah, here's the example. Find the length of the missing side of the right triangle in the figure below. So we need to find a from hypotenuse of 12 and the other side of the right triangle is 4. So yeah, we can apply the formula. So a squared plus 4 squared equals 12 squared. So a squared is 128. So a is square of 128, and it is 8 times square of 2. Okay, so far we have solved for linear equations, rational equation, and quadratic equation using several methods. But actually there are many other types of equations, and we'll investigate a few more types in this section. Actually, it'll span to up until the next video. And we'll look at equations that involves the rational exponents, polynomial equations, radical equations, absolute value equations, equations in quadratic form, some rational equations that can be transformed into quadratics. Okay, the first equation that we're going to discuss here is a rational exponent equation. Okay, so what is a rational exponent? Rational exponents are exponents that are fractions, where the numerator is a power and the denominator is a root. For example, 16 raised to the power of half. So it's another way of writing square root of 16. Or 8 raised to the power of 1/3. And it's another way of writing square root of the third power root of 8. And the ability towards this ratio exponent is a very important skill and sometimes used in calculus later. Okay, so there's a reason why sometimes we want to raise the equation to reciprocal of the exponent. Okay, because we want to eliminate the exponent of the variable term and number multiplied by its reciprocal to be equals 1. For example, we make the exponent to be 2/3 times 3/2 that equals 1, or 3 times 1/3 is 1, and so on. So there is a formula that I need to remind you. So a raised to the power of min is actually the same thing as a raised to the power of the reciprocal of n, and together it is also raised once again to the power of m, are also the same thing as a raised to the power of n, then once again raised to the power of the reciprocal of n, and this is the same thing as taking the square root of power n of a raised to the power of m, and also the same as taking square root of a of the power of n raised to the power of m. Actually, there are many ways of expressing the same equation. So now let's practice our this concept, okay, by solving this problem. So evaluate 8 raised to the power of 2/3. So whether we take root first or power first actually depends on the number, right? You are free to choose it. Choose the one that suits the problem and make you easy to solve for it. So here I think that it's much easier for you to take the cube root of 8 first, then square it. So cube root of 8 is clearly 2, and then we square it, and the result is 4, right? The second is x raised to the power of 5/4 equals 32. So here maybe it's better for you to raise both sides to the power of 4/5, and you know that 32 raised to the power of 1/5, I mean take the fifth root of 32, it is 2, okay, and 2 raised to the power of 4, it is 16, So x is 16. The third problem, the third example, also the same. I want you to pay attention to how to solve it. This time you may want to uh, pay attention that the denominator of the exponent is not the same. So you need to do some manipulation first before you get the solution, which is 0 and 1/81st. So we have used factoring to solve quadratic equation, but it's also a technique that we can use in many type of polynomial equation. Once again, what is polynomial equation? Okay, polynomial equation is a equation with degree higher than 2. So we still need factoring. Let me show how to do the factoring with this. For example, we have an equation which is 5x raised to the power 4 equals 80x squared. So first, let's set the equation to be 0. Then find the GCF. Here the GCF is 5x squared. So do factor and 5x squared times x squared minus 16. And it's clear that x squared minus 16 is much easier for us to solve. So x squared minus 16 actually can be factored to be x minus 4, x plus 4. So x minus 4 yields 4, x plus 4 yields minus 4 to the solution. And for the x squared, it must be 0, right? But this is double solution actually. So the solution are 0, 4, and minus 4. And here's the graph showing you how to plot these equations. Okay, you evaluate by yourself. And the second example on this is solve a polynomial by grouping. So the equation is actually, I'm sorry, actually that is not x squared plus x squared, but x cubed plus x squared minus 9x minus 9 equals 0. Sometimes I mistype it because I prepare it online. I'm sorry. So x cubed plus x squared minus 9x minus 9 equals 0. So we need to group it. So x squared x plus 1 minus 9 x plus 1. So you see, can factor it out now. So x squared minus 9 times x plus 0, x plus 1 equals 0. For x squared minus 9 can be factored to be x minus 3 and x plus 3. X plus 1, x plus 1. So x minus 3 yields the solution to be 3, x plus 3 equals 0 yields solution minus 3, and x plus 1 equals 0 yields the solution minus 1. So there are 3 solutions to this problem, or to this equation. And here is the figure. I also want you to learn how to plot the figure by yourself. Okay. So we'll look at solving quadratic equation by factoring when the leading coefficient is 1. This is done. But when the leading coefficient is not 1, then we can solve by grouping 2. So grouping requires 4 terms. And let's see that we can do it. So it is done as shown in the example previous. Okay. Now we are done with the equation that involves exponent, rational exponent. Now we'll discuss about solving radical equations. So what's actually a radical equation? Radical equations that contain variable in the radicand. For example, square root of 3x plus 80 equals x, or square root of x plus 3 equals x minus 3, or so on and so on. So radical equations may have one or more radical terms and are solved by eliminating each radical one at a time. Okay. So given a radical equation, there are some steps you need to follow to solve it. Okay, 1, 2, 3, 4, 5. There are 5 steps total. I want you to read it by yourself. Okay, and I will explain how to apply these steps while doing the example. Here's the example. First example: square root of 15 minus 2x equal x. Solve it. So it's very simple. So the radical is already isolated on the left side in this problem. So you just need to proceed by squaring both sides. So by squaring both sides, it yields 15 minus 2x equals x squared. And then we just need to move all the terms into one side. For example, we move it to right side here. So x squared plus 2x minus 50 equals 0. And now we can factor it, right? To be x plus 5, x minus 3 equals 0. and this will give a solution x minus 3 x plus 3. But this is just the proper solution. We need to check it back to our original equation to show if both a solution is valid or not. First check with x minus 5. But actually this yields that square root of 25 equals minus 5. It is not true because square root of 25 is actually plus minus 5 if you want to consider plus minus, but actually if you don't want to consider the plus minus, it's just positive 5. So positive 5 is not the same as minus 5, it's not equal to minus 5. So this is an extraneous solution. So let's check for x equals 3. And this time it's true. So the solution is 3. And this is the only solution to this problem. Number 2, so solve for square root of 2x plus 3 plus square root of x minus 2 equals 4. And also this equation contains two radicals. And to isolate one radical, eliminate it and then isolate the second radical. How to do it? Okay, for example, we move one of the radicals, say that this time we want to move the square of x minus 2 to the right side. And after that, we need to square both sides, and it yields the for the equation as shown in the slide after doing some simplification, which is x squared minus 22x plus 121 equals 64x minus 128. Okay, so now that both radicals have been eliminated, then you can set the quantity equal to 0 and solve it. And then you can factor it to be x minus 3, x minus 38 equals 0. So the solution are, the proposed solution are 8 and 38. But we still need to check the solution to the original equation. For x equals 3, then 3 equals 3, then this is the solution that we expect. But for x equals 83, I mean, that it yields 13, which is not equal to the right hand side, which is minus 5. So this is just extraneous solution. So the only solution to this problem is 3. And we have done with today's lesson. Okay, so here's a little quote for you today. So Hazrat Inayat Khan once said, some people look for a beautiful place and others make those places beautiful. So thank you for watching. Keep watching. Subscribe, give a like, comment, share this video to your friend. I'll be back on every Tuesday and Thursday. Keep watching and be thoughtful. Bye. See you.